All right, guys, it is time to review our topics from Chapter 3. So we're going to start with symmetry within functions and how to algebraically identify that symmetry. So the first section here is about identifying symmetry with respect to the origin. So that means, does this function have rotation symmetry with the origin 0, 0 as the center of rotation? So here's how you algebraically find out. You test, does f of the opposite of x equal the opposite of f of x? F of the opposite of x is 3 times negative x to the 11th power minus 6 times negative x squared. An odd power will not cancel out all of the negatives, so this is going to be the same as negative 3x to the 11th minus, and this is an even power, so it will cancel out this negative. However, this one is not canceled out, so we have minus 6x squared. The opposite of f of x means negative distributed on the original function. And that gives me negative 3x to the 11th plus 6x squared. And notice that this and this are not exactly the same. So the answer is no, it does not have symmetry with respect to the origin. Number 2, h of the opposite of x is negative x over 5 times negative x squared. That negative has an odd power, it's the first power, so that negative is going to stay. This negative has an even power, so that's going to cancel it out, so we have 5x squared in the denominator. The opposite of h of x is negative x over 5x squared. And this negative in the front, I can leave it in the front, or I can put it in the numerator or the denominator. Now, this one over here has one in the numerator, so I'm just going to match that. And these two match. Now, what if I put that negative in the denominator instead of the numerator? Doesn't matter. It has the same value. If I put this negative in front instead of in the numerator, it doesn't matter. A negative in a fraction makes the fraction negative. So no matter where I put this negative, it's still going to have the same value as this original, or of the h of the opposite of x. So the answer is yes, it does have symmetry with respect to the origin. Y minus 7 equals x. Does that have symmetry with respect to the x-axis? To find out, I'm going to change y to the opposite of y. Because if there's symmetry with respect to the x-axis, that would mean I can flip it over the x-axis, and whatever y value I see, I would see the opposite of that same y value as well. So the question is now, can I make this match this original? And this y is to the first power. That's an odd power. That is not going to make that negative go away. The right side already matches, the left side does not. So no, there is not symmetry with respect to the x-axis. Symmetry with respect to the y-axis, to test that, I'm going to put in the opposite of x. Because symmetry over the y-axis, whatever x value I see on that graph, the opposite of that x value will also exist. Now, right now, I've got the left side already matching, and this negative is not going to go away because it's to the first power, so it's not an even power. So the right side is not going to match. No, there is no symmetry about the y-axis. Next is symmetry about y equals x. If there's symmetry about y equals x, then every point xy, point yx is also going to exist. So I can switch my x's to y's and my y's to x's. And if there is symmetry with respect to the y equals x, then I'll be able to algebraically make that match the original. So what I'm going to do is get x by itself so it matches this, and then just see if the other side matches the original. So to do that, I'm going to move this 7 over. It's going to become x equals y plus 7. I've got x equals in the original and now. I've got y plus 7 over here, but this was y minus 7. Those do not match. So no, there is not symmetry with respect to y equals x. The last one is y equals negative x. If there's symmetry with respect to the line y equals negative x, then every point xy, you'll also see the point negative y negative x. So what that means is if there is symmetry about this line y equals negative x, then I can switch my x's and y's and give them opposite value. So y becomes negative x, and x becomes negative y. Can I make that algebraically match the original function? So I'm going to move that minus 7 over there. I get negative x equals negative y plus 7. And if I multiply both sides by negative 1, I'll get x equals y minus 7. And both sides of this match this original. So I'm going to say yes, there is symmetry with respect to the line y equals negative x.